Hello and welcome to Aerospacery. Today, my fellow aero enthusiasts, we have a very special guest joining us for an interview. He is a NASA astronaut who has logged over 26 days in space on 2 International Space Station construction flights, STS-116 and STS-130. He has logged 18 hours on EVAs during 3 spacewalks. Nowadays, he serves as a Senior Director of Human Integration for Blue Origin and a Launch Director for New Shepard. He's a hero, he's kind of a badass, but most importantly, he's a dear friend. I'm very happy to introduce my friend, Nicholas Patrick.
Hello, Karina. Nice to be here.
It's great to have you, buddy. I'm glad you could make the time, and because I know you are a much busier person than I am, but thank you. And I thought we'd start today's conversation by maybe diving into your astronaut training, because it seems like training for that kind of experience is a really physically and mentally intense thing. So what kind of unusual training have you done historically?
Well, when you show up at NASA as a new astronaut, Karina, you spend about 2 years as what's called an astronaut candidate, or affectionately an ASCAN. And they give you all sorts of training in that 2-year period. Obviously, lots of training on space shuttle systems, in my day, space shuttle systems. And today it would be on space station systems primarily. They give you training in the kind of science that astronauts are asked to participate in or help perform on orbit. They give you some basic EVA training where they put you in the neutral buoyancy lab underwater. They weigh your suit out until it neither sinks nor floats, hence neutrally buoyant. And they take you through the basic tasks of a spacewalk, how to get in and out of the airlock, how to move around on the handrails, how to make sure your tether is always attached so you don't float away, all those things. And then, of course, there's the T-38 flying training. You need to go through a component of Navy survival training to fly in the T-38, because you sit in an ejection seat and you could eject over water or over mountains or the forest somewhere. You get to start out as a brand new backseater or front seater in the T-38 and learn the ropes. So all of this keeps you really, really busy for the first 2 years.
Wow, that is a lot of training. Do you suppose that maybe they incorporate so much variety to see what you're best at, or just to more so prepare you for the variety of situations that could come up?
It's mostly to prepare you for the broad variety of situations that could come up, as you say, and the broad variety of tasks that a modern astronaut is asked to do. Not just fly the vehicle like the original astronauts, but participate in the science, perform outreach to students and others. So there's really a lot of different things. But also, they are observing you the whole time. I remember in the classroom where we were doing our science and space shuttle and space station systems classes, there were 2 big cameras at the front that would occasionally pan around the room and watch what kinds of questions we were asking. And I don't know who was sitting at the other end of that camera, but I'm sure they were taking notes about us, because NASA needs to be able to rely on the people it sends to space, not just to do a good job, but to represent the agency well.
Yeah, it's kind of an expensive gig, and it's not getting less expensive anytime soon, I imagine. So you have to be able to rely on books.
I hope it does get less expensive. I think that's the whole reason for these new space companies, is to reduce the cost of access to space so we can put industry there. But back to training. You asked about unusual kinds of training. Once you've finished your basic 2 years, you get a technical job in the astronaut office. And that could be, you could be following one of the vehicles, say a SpaceX Dragon vehicle, or you could be helping with medical issues in the office or management. And then when you get assigned to a flight, you get what we call mission-specific training, where you get trained on the actual vehicle you're going to fly and the actual tasks you're going to do. And that's another exciting thing. But NASA also throws in what I'll call expeditionary training events. They will send, for example, a newly assigned crew out together to do 10 days of sea kayaking or 10 days of hiking, backpacking, because there's no better way to learn about your crewmates than to experience hardship with them, to experience difficult situations and make decisions together.
Yeah, I would completely agree. You can actually see how people are going to react when they're faced with stressful situations. I mean, they say that, I don't know if you've ever listened to a gentleman called Jocko Willink. He talks about his Navy SEAL training and talks about the kind of people that actually can make it through something like that. And, you have to have a certain kind of personality and be able to measure yourself against the amount of stress that you're going to be faced with, and also be able to rely on the people next to you.
I think that these are skills that some people have and others have maybe not as much of, but they're all learnable skills. It's things like self-care, knowing your limits and how to look after yourself, because if you don't look after yourself, somebody else has to. It's knowing how to be a good leader or a good follower. Not everybody can lead all the time, and sometimes most of the team has to follow well, which sometimes
that's a great point.
Following decisions that you didn't particularly agree with. But if we don't all go in the same direction, we won't be a team anymore. So there's a lot that you can learn on these, not just about each other, but about yourself and about the way to get along as a team.
So there's also some underwater training.
Yes.
Would you mind expanding on that? How does that differ from sort of being in space?
So one of the best analogs for spaceflight is underwater training. And I've already mentioned what we did at the Neutral Buoyancy Lab. That was just a 40-foot deep pool. Well, it was the largest pool in the world, probably still is. 40 feet deep, 200 feet long, and 100 feet wide. And I think filled with 6 million gallons of water. Large enough to hold an entire mock-up of the US half of the space station. So you could go down, be neutrally buoyant, and practice your spacewalks. And it's really pretty much like floating around in space with a few differences. NASA expanded on this idea with something called NEMO. I think it was the NASA Extreme Environments Mission Operations training. And we partnered with NOAA to use their habitat called Aquarius, which is off the shore of Key Largo, a few miles, in about 60 feet of water. And astronauts would go 4 at a time to live on Aquarius for up to 10 days. And Aquarius essentially had an airlock. It had what they call a wet porch, but it's a separate area where you can go out of the habitat. And then there's essentially a room with a hole in the bottom, and the air pressure keeps the water out, but you can climb downstairs in scuba gear and go out and do the equivalent of a spacewalk. You have to live in this Aquarius habitat, which is really small. It's about the size of a small school bus, with 6 bunks stacked 3 high at one end, and then living spaces in the middle, and the area for science. And at the other end, this wet porch that I mentioned, where you can go out and do your EVA, kind of like an airlock. So this is a great analog for spaceflight. You get to do spacewalks, you get to be remote from your mission control team. You have to live and work in confined spaces with other astronauts that you may be flying in space with one day. So a really great analog for spaceflight training, and really, really fun to boot. If you love scuba diving, as you do, I know, it's really fun.
Yeah. You and I have talked about scuba diving before. It's super fun when all the gear works as expected. But that sounds like the perfect way to actually practice for kind of being in tight quarters and possibly stressful situations, but also kind of really get into the idea of being in a space station. Because you can't necessarily just go outside.
Another thing that's great about being underwater, I say great, but great in the sense that it's a great analog for spaceflight, is that your life depends on your equipment, both its reliability and the extent to which you can operate it properly. And they gave us lots of training on scuba equipment. We were all scuba divers anyway, astronauts have to be. But they gave us lots of specific training on the NOAA scuba diving setup, which for those who are scuba diving aficionados, it's like a cave diving setup with multiple tanks, a manifold between them that you can isolate one tank from the other, and a regulator coming from each tank. And very special procedures for both going to your reserve air and sharing air with a buddy. So we practice a lot of these things, and it becomes second nature to use the equipment in the appropriate way. And that's the kind of mental attitude that you need to be an astronaut. The things that are safety critical need to just happen automatically when the time comes.
Yeah, it's absolutely critical that the equipment works in space too. So, getting in that mindset where you're actually just kind of ramping up your equipment, doing all your checks, making sure your buddy is good and you're good, and then you have everything in front of you before you actually engage in some sort of critical outside the vehicle operation or inside the vehicle operation for that matter. In previous conversations, we've talked about maybe other ways to train for being an astronaut. And you had mentioned something that I thought was kind of a cool idea, and I was hoping you could expand on that.
The sailing idea that we talked about. Yes.
Yeah.
I like to sail on the side, and I don't mean race. I mean do cruising sailing, where you pack a boat with supplies, and you get a crew together, and it's a decent sized boat, and you go off for a week, and potentially don't resupply the boat, and maybe don't even touch dry land. And that to me is a lot like spaceflight. The idea that you have a vehicle, you have to provision it, you get onto it, and then that's where you live in tight quarters with half a dozen other people for the rest of the trip. And
just like in Nemo.
Like Nemo, except this vehicle's moving and you have to control it. Nemo, at least, was stationary on the ocean floor. But with a sailing vessel, you have to take it somewhere, and you have to make all sorts of decisions about where to anchor for the night, how to operate the systems, when to conserve electricity, when to conserve water. So in that sense, it's really just like flying in space. It's a wonderful analog, and the close quarters and the reliance on each other to do some of the hard work, like raising and lowering sails. I think sailing has a lot to offer to astronauts.
Yeah, it's a great way to put it too, because I know you mentioned the fact that you have to actually operate the vehicle and park it and rely on your GPS systems, and no, it's actually it would mirror a lot of the way people are expected to actually operate on a space station as well. But. Yeah.
Harder to do spacewalks from a sailboat, although I suppose you could scuba dive off the side.
That's what I was thinking. Yeah, absolutely. You could actually sail to an in-ocean Nemo site, and actually
drop anchor and dive over the side.
Drop anchor, go in, and for sure. Now, that would actually be maybe future astronaut training. Who knows?
What all these things have in common, Karina, is that they're all unforgiving things to do. They're all endeavors where you can't really afford to screw up. And spaceflight's very much like that. You can't afford to make mistakes. So you have to help each other, catch each other's mistakes, work as a team.
It always helps to have a second set of eyes and a second set of hands, for sure. It's rely on your buddies and yourself. But
the crucial thing in what you said is the second set of eyes, with eyes that belong to a person who understands what the tasks are and can keep an eye on you, so that you don't make mistakes, or that they catch them if you do.
Oh yeah, well, I mean, just being a human in general, there's 100 things that are always going to go through your head, and sometimes you're not going to always catch the thing in front of you. So having that other person there with you to kind of walk through the process and help you make sure that you're doing the task correctly, it makes 100% of the difference. I would like to maybe kind of lead into talking about launching into space now, because this is a powerful idea. The fact that we're able to launch out of our Earth's atmosphere. And I was going to talk about the STS-116.
Mm-hmm.
This was a 7-member crew that you were on, and you were on a 12-day mission. So let's journey back to the year of 2006. And on a 12-day mission, it kind of feels like that's almost the extent of like a vacation, or but so first of all, like, what does it feel like to sit on top of a massive rocket?
Well, most people ask, is it scary? And the answer is no. You're too busy thinking about your tasks to be very worried about the space flight. But it is, how do I describe it? Perhaps intimidating. It's a very serious day. You know you're about to get onto a rocket that intellectually you know is potentially a dangerous thing. The space shuttle, didn't have an accident-free program. But mostly astronauts get on board thinking about what they need to do, because there are thousands of things an astronaut is going to do in that 12-day mission, and hundreds of them happen during launch and ascent and immediately after you get to space. And the world is watching. Your crewmates are relying on you to do everything that's on your plate accurately. So astronauts generally are strapping in, thinking about their tasks.
So you're literally, your mind is so overwhelmed with all these tasks lined up that it just worrying is something you have to kind of compartmentalize, probably.
Well, there's just no time for it. Yeah. It's easy to compartmentalize the worrying because there's just no time for it. We are totally preoccupied with the task at hand, which is getting into the space shuttle safely, strapping in, configuring all the switches, launching, and being ready at a moment's notice to execute one of many off nominal or contingency procedures to help get us home, potentially in only minutes if something went wrong. So you're just completely preoccupied with those thoughts.
That's fair. Yeah, I mean it's dangerous. There's 100 things that have to go right, more than 100 things that have to go right when you actually launch, land, or anything else in space flight. So being concerned with your tasks is going to occupy a great deal more of your attention. But so I guess I have to ask, just kind of also leading into the topic of the day, where the SLS is taking a while to get up into space. Were there any kind of scrubs or any kind of delays or worries about just the initial? Yep.
Both of my flights we scrubbed and had to launch a day or two later. And
do you recall what happened?
Part of the space launch business. For a rocket to launch, forget what the crew has to do. A million things have to go almost perfectly. Well, there are some margin, but a million things have to go almost perfectly for the vehicle to be ready to roll out, to be fueled, to be checked out. And ready to go, ready to launch. And if any of those things don't happen, generally speaking, you scrub the launch. So I would say, for all the launches I've been involved in, the success rate's actually very impressive. If you think that any one of a million things could stop you from launching on any particular day.
The fact that you're still here actually is a success story in itself, because, I'm old enough to remember when the Challenger thing happened, and that was harsh. That was terrible, and people learned valuable lessons from Challenger, and then again, sadly, we had to learn lessons from Columbia, and I think I see real evidence of those lessons being applied to all the launches that came after them. We became more cautious about the things that mattered, and I think that's at least a good outcome from those tragedies. I am seeing that, especially with the fact that NASA is more willing to scrub more and just kind of take a step back and really look at the problem and make sure they're doing it right, which to me that matters, because it's not just billions of dollars of infrastructure. These are human lives and the people that they touch and their families, their children. It's just
Yeah. Well, and not only are we better at decision making, I think, and setting expectations about the likelihood of a scrub, but the newer vehicles actually have something in common with the very first vehicles. It's easier to rescue the crew from a bad situation. And to explain what I mean by that, I have a little prop here. This is my model of the space shuttle. And as you can see, the crew compartment in the space shuttle, this is the piece where the crew live, 7 people in that small area, is attached to what carries the payload bay.
Okay.
And if something goes wrong with the shuttle or the rocket stack that it's sitting on, if something went wrong, you couldn't separate just the crew module and bring the crew back safely. You had to do something with the entire shuttle, which was often possible, but very difficult. Today's rockets I think all have something interesting in common. They have escape systems. These are either pusher or tractor rockets that help pull the capsule off the booster when something goes wrong. And those systems allow you to get the crew away, just the crew, which is really the only thing that's not replaceable here. Just the crew away from the rocket very, very quickly. And the more quickly you can do it, the wider range of problems you can deal with safely.
Is this similar to the Blue Origin escape system that they have on their New Shepard?
Yes, it is. And all manufacturers now are putting escape systems into their vehicles and keeping the crew compartment as small as they can. And actually, if you look back, it's the same capability that Mercury, Gemini, and Apollo had back in the 50s and 60s. So, as they say, there's nothing new under the sun. Well, escape systems aren't that new, but the shuttle didn't have one. It had a limited capability for astronauts to blow a hatch and then parachute out. But that only worked within a certain range of speeds and altitudes.
Yeah. If you're really high up and there's probability you're going to burn up in the atmosphere. And
if you're high up, you're going very quickly, and your spacesuit's not designed to dissipate energy.
No.
In a ball of plasma. If you're very low down, there isn't time to get out. So there's a window between those two things where that system of jumping out of a hatch with a parachute works. Thank goodness we never tested it.
Yeah. It's always good to have them. It's better to have it, not need it, than to need it and not have it.
Yeah, I should correct myself. We did test it long before I joined NASA, but we never had to use it in anger, and I'm grateful for that.
Me too. And I'm glad things are getting better for NASA and their projects, even though SLS has been delayed. It's fine. They know what they're doing. It's
so much more important to get it right though than to do it quickly.
Oh yeah, for sure. So I'd like to talk about living inside the ISS, if we could, please. Because like I said before, this is kind of a 12 days to me. That's the equivalent of a vacation, but you're also working consistently during this process. You're employed to do all sorts of different tasks while on the ISS. But I mentioned, is there ever any time to actually just sit there and be a person and kind of look out the window and go, holy shit, I'm in space?
Yeah, the view is spectacular. But no, you hit on the main problem with enjoying the view, which is that you're very busy. You're up there as a paid astronaut, not to have fun, but to help construct the space station or maintain it or resupply it or do some science. And those things, on top of getting 8 hours of sleep a day, if you can, or maybe 6 or 7, and eating the meals you need to eat to stay functional, those things take up almost all the day. I think our days were scheduled in 5-minute increments from shortly after we woke up until an hour before we went to bed, or an hour and a half before we went to bed. And that hour and a half was supposed to be personal time, but invariably, most of us used most of it to catch up on things that hadn't gone quite as planned during the day and therefore hadn't ended on time.
Oh, man.
So I had hoped to send lots of email to friends and family, but it was hard to send email. It was hard to find the time.
You actually you can send things like emails. That's interesting.
You can send emails. And with attachments, you can have teleconferences with your family. But the everybody's favorite thing to do, of course, is to enjoy weightlessness and to enjoy the spectacular view from 250 miles up.
Yeah, I mean that's $1 million view. But
it's really spectacular. The Earth is much more beautiful in reality than the photographs suggest. The photographs are spectacular.
I believe it.
Videos, you've seen movies of high-def movies of the Earth viewed from space. They're really spectacular. It's even more beautiful when you see it in person.
Well, you're making me sad I didn't join the Astronaut program. But, gosh, I had a question, but it kind of flittered off. But I will say, do you miss anything about living in that situation, or are you just too busy to kind of settle for a minute?
No, I miss being in space. It's really special. There are some things that are difficult. I'll come back to those. But the things that are easy, moving around. You can move around effortlessly once you learn the technique. It doesn't take you can move around with basically fingertips applied to walls. You can push off gently and float across a module. Eating's fun, but a little bit challenging because the food doesn't go down into your stomach as far as you would expect it to here on Earth. Bounces around.
That's another thing I was going to ask about. We'll get into that in a second, but yeah, please go on.
And then there's the view. And maybe I've missed the most important but intangible thing, which is when you're on a mission, a NASA shuttle mission going to the International Space Station, you know you're doing something important, important for the future of humanity, important for spaceflight. And it's really special to be part of a large team that's doing something like that.
Yeah, I can imagine. It feels like, okay, I've done something today. It doesn't matter if I only slept 2 hours. I did stuff. Because you only have so many hours that you're going to be on Earth or off the planet. And I get it. You know, because those stressful situations, sometimes you put up with it just to have those kind of moments. So you mentioned kind of having that connected feeling when you look at home, looking down on the planet, and you feel like you're more connected to Earth. But and you've also mentioned that you were quite busy, just doing all sorts of tasks. Let's maybe circle around to the unglamorous details about living in space, just because I don't know. We could share all kinds of fun stories, like the Instagram version of space living. But I thought, let's touch on being an actual person and talk about some of the gross things about maybe being in space.
I don't know that much of it's gross, but a lot of it's really challenging in sometimes annoying, sometimes difficult ways, sometimes fun ways. For example, you can put your pants on, your trousers on, 2 legs at a time in space. That's easy. That's kind of fun. But while you're doing that, you will be tumbling around the inside of your space shuttle or space station, bouncing off walls, bouncing off other people who may be eating. You learn very quickly that what matters in zero-G is to minimize your movements. Never make a big movement. Never give a big push.
So no interpretive dancing.
There was a story I learned, maybe apocryphal, maybe real, of an astronaut who found themselves for the first time in zero-G, wanted to go to the far end of the module and pushed off mightily with their legs they felt like they were jumping, I guess, up high. But they weren't. They were going to float across in zero-G, but the big push they gave themselves meant they were going very quickly. And about halfway down this module, they realized all they had now to stop themselves was their hands and their head, which aren't nearly as strong and robust as their legs were. And so apparently they hit the far end fairly hard. And that was one of the things that, we all heard and we all learned from. Push off gently. You can go faster when you get better. But like everything in life, learning to drive, start slowly.
Fair enough. Yeah, absolutely. Baby steps, especially when you don't have gravity to assist you because...
And everything's different. Also, if you move around too quickly, you tend to what they call it spinning up your gyros. You can get motion sick from quick movements in zero-G.
Really?
And a case in point was coming from the space station to the space shuttle. The space shuttle docked to the space station. Here's the space station like this.
Yeah.
And so you'd go along the space station's axis, along the modules, into the docking port, take a right angle turn that way, and now what you would think is up in the space station is actually forwards on the space shuttle. And then you would grab onto some handrails and swing around and go from the shuttle airlock to the mid-deck, up the ladder to the flight deck. And this was a large number of right angle turns that you could do pretty quickly by grabbing a handrail as you passed it and then letting go after you'd turned 90 degrees.
Okay.
But if you did it quickly, especially if you weren't well adapted to space, it would make you sick. Make you nauseous anyway, not sick necessarily, but it would make you nauseous. And you had to learn to slow down. You had to learn to slow down when you're eating as well. You can't gulp your food down. You can't get very large amounts of food very quickly to your mouth on a fork or a knife because they tend to float off. And
wait, so there's actual forks and knives involved?
There are
I thought
actual
it was all
forks,
just kind of in Capri Suns.
Not much in the way of knives, but we used forks a lot, essentially, or spoons. You could eat moist food with a spoon.
Okay.
It's not gravity holding the liquidy food into the bowl of the spoon. It is surface tension. The food kind of gloms on, and you just have to move it slowly, because if you move the spoon with food quickly, the spoon will outrace the food, and then the food is unmanaged. It's now a little ball of something moving on its own, and it will invariably find the cleanest shirt on the crew and go flat. A friend of mine flew some cookies. They were really nice cookies, butter cookies, and he remembered halfway through the mission that he had these cookies. And he said, let's eat the butter cookies. He went to get them from a mid-deck locker, and there were a tin of cookies. And he was so excited. And he undid the tape around the edge of the tin. He opened the tin, and a cloud of cookie dust went out like a miniature slow motion explosion from this tin of cookies, because the cookie tin had been shaken during the fairly violent shuttle launch that we were on a few days earlier. And none of us stopped to think about what shape these cookies might be in. These crumbly butter cookies might be in by that point in the mission. But we spent a fun few minutes basically hovering around the mid-deck like goldfish with our mouths open, sucking in.
I was going to ask, because if I had a special treat on board and it did that, I would definitely make the extra effort to go kind of around like a little frog or a fish and just kind of gobble it in the space station.
You do have to be careful not to inhale the food, but yes, it's really fun. And we would play with M&Ms. We would fire M&Ms to each other, and you just basically aim them at somebody's mouth, and they slowly go in a straight line across the module, and somebody can get them a few
have like competitions later. Or something.
Really fun. So those are challenges, but they're fun challenges. The challenges that are less fun are using the bathroom in space, or say washing and shaving in space. We'll talk about the bathroom for a second. The space shuttle had a waste management system, it was called, rather euphemistically, that was a toilet. But unlike an Earth toilet, which works with gravity, everything you produce falls down into the bowl and is covered with water, which limits the odor, and you just flush and it's gone, right? Well, in space, with essentially no gravity present, there is actually gravity, but you feel like you're weightless. Everybody's floating. All the byproducts of your digestive system would also float. So you sit on a toilet that now, instead of using gravity, uses gentle airflow into the toilet to help keep everything where you want it, in a giant bowl underneath the seat. There's a separate funnel and hose for peeing in. And these things take some training. They're not easy to use. In fact, they're complex enough that there's a checklist, a fairly short checklist for using the urine collection system, but a fairly long checklist for using the actual toilet. And you have to configure everything just right. Opening valves, turning on fans, powering up the system, and so on, and then making sure you leave it spick and span, really clean for the next user. You don't want to make enemies by leaving a messy toilet.
No.
So it's an interesting challenge.
Because it's not like you can just leave the building and nobody will know. You're like looking over at like crew member number 5, be like, I know it was you, Betty.
But with every challenge comes a fun piece of spaceflight. So, for example, the toilet, the waste management system on the shuttle, you opened a door to get to this very small room, but the door had curtains that you could then put around to make a sort of small private space.
Okay.
And in that private space was the side hatch for the shuttle. And in that side hatch is a window. So this was an outhouse, as it were, with the very, very best view in history. Right? You could look out that window while you're sitting on the throne, and you could see thousands of miles off to the left-hand side of the space shuttle, just the left-hand side.
And some planets over here and some planets over there.
So that was the silver lining to the cloud of having to use a tricky system for going to the bathroom in space. Showering, people tried showering on Skylab. I think it's a bit of a waste of water. The way we kept clean was we used wet washcloths wetted with warm soapy water, and you basically just use the washcloth on your body.
Yeah, that's fair.
You don't get that dirty in space.
Yeah, I mean,
because
You're not
you don't use the
working
big
too
muscles.
hard. You're not sweating as much.
You're not sweating that much unless you try to, unless you go do exercise in space. Just moving things around. Again, it's like everything else. It's done with a fingertip push, and it's really about technique and not letting massive things hit important other things like switches and displays. So you do everything slowly, and you don't tend to overheat very much.
Well, how about the exercise in space? I know that NASA has been kind of emphasizing the necessity for folks to engage in more exercise simply because they lose a bit of bone mass while they're in extended space missions. Is it maybe, I guess it would be more difficult to stay clean. And did you guys have any kind of exercise program during your missions?
For our 2-week shuttle missions, even though they were to the space station, they weren't considered long enough that exercise was mandatory for me, for example. I did do some, mostly so that I had the experience of exercising in space, which is interesting. The machinery doesn't work the way it works in 1G. For example, in 1G, if you want to use an exercise bicycle, you just sit on the seat. And when you push down on the pedals, that's your weight pushing down and you don't move anywhere. If you tried to sit on a terrestrial exercise bicycle in space and you push down on the pedals, you would just go up off the seat towards the ceiling. So the exercise equipment is designed a bit differently, and it has to be used a bit differently. And you do sweat, and then, of course, you have to clean up afterwards. But exercise is really important for people who are staying more than 2 weeks. For people who are spending 3, 6, 12 months in space, if they don't exercise, as you said, they lose bone density, particularly in some very important parts of the body, the wrist, the top of the femur where it attaches to the hip. Places that back on Earth, it's really important to have good bone density and strength so that you don't injure yourself when you get home. And of course, they also lose muscle mass if they don't exercise. And I think people who are used to exercising just feel better when they've exercised. So it has a psychological support function as well.
Yeah. It actually is really beneficial for your mental state and acuity, and it's keeps you sharp and actually helps balance out the hormones. But do you still keep in touch with your crewmates?
I do. Some of them particularly. I just talked to one of them a couple of days ago. So yes, you when you've flown in space with people, it's a very special experience. It's a bonding experience. You become a close-knit, hopefully highly effective team. And I think on my 2 shuttle missions, we were highly effective. And so you do build a special relationship with people. And also the folks I worked with at NASA were an extraordinary group. They were just great to work with. You wouldn't want to lose touch with folks like that because, you've all had this amazing experience together, just kind of the once in a lifetime, or for you, twice in a lifetime. And it's... maybe 3 times, Karina, maybe 3 times. We don't know.
Fair enough. I guess we'll circle around to that. But can you take me back to your first EVA and describe the moment when you stepped into the vacuum? Because it's an interesting experience the first time. But let me back up a little bit. By the time I flew on that mission in 2010, I'd been an astronaut for 12 years by the time I did my first spacewalk, and I'd had spacewalk training, EVA training, on and off for, it must be 10 of those 12 years. So the training in NEMO.
The training in the neutral buoyancy lab.
The neutral buoyancy lab, yes.
And I'd started off as an ASCAN getting some basic EVA training, and then I'd done the EVA skills course, and then I'd occasionally done EVA training in the intervening years, on and off, little bits here and there, just to stay current. And then I did a lot of it when I got ready for STS-130. So I was very, very well trained, not just in the general skills sense, not just knowing how to get in and out of the airlock and use safety tethers and use tools, but we had mission-specific EVA training where we learned to do the specific tasks. And at the end of the training, we put those tasks together and ran the EVAs for time to get the actual time it would take to do the EVA.
So that actually answers one of my questions that I was going to follow up with, because I had to wonder, when you're putting yourself in that situation, do you ever have that moment where I don't know if I've had enough training? But it sounds like you were doing it for a while.
I always felt like I had enough training. But the first time I I actually went to do a spacewalk, I realized this one's different. I won't have any divers in the pool to help me if I get in trouble. I'm out in vacuum. I can't just somehow get to the surface of the pool if there's a problem. I have to sort everything out for myself or with the help of my EVA buddy. And that's different. And then I also remember stopping to think, what's it going to be like to go out of the ISS EVA hatch for the first time? It's 250 miles up. The hatch is facing down, and that's a long way up. And am I going to be comfortable? I like heights, but I still stopped briefly to think, am I going to be comfortable with this, or am I going to feel weird and maybe even worried? And what was interesting is, my EVA buddy Bob went out first. He was EV1, and he went out head first and waited for me outside. I came out second because you only go out one at a time. I went out feet first. It was dark outside, which maybe was a blessing mostly because I wasn't distracted by looking at the earth below. I went out. I got my head below the level of the hatch, and now I'm hanging underneath the space station by the handrail with a tether connected to the space station. And EVA spacewalkers use a couple of tethers. They use a long tether back to the airlock, but they also use what's called a local tether with a big hook on it, and you put it down on a handrail right where you want to work. So I put my local tether down on the circular handrail around the airlock opening. And Mission Control said, okay, Nick, you're out. We see that. Why don't you do your basic EVA maneuvers? And I remember thinking, okay, I remember what those are. Pitch, yaw, and roll. So when you want to roll left and right, you put your hands up on the handrail and you do this, and that's very easy. One up, one down, and your body just basically responds in roll. Okay. And when you want to yaw, that's easy. One forward, one back, and your body just does this. It yaws left and right. But when you want to pitch, you have to do something a bit different. The only way to pitch on a handrail is to twist it really hard. And people who spend time doing that run out of strength in their forearms very quickly. So that's strongly discouraged. What you do instead is you move your hand to the middle and you push above and you push below to pitch yourself in and out. That's the third axis you can control. And I remember doing those things. Mission Control was watching on a camera, and they went well. Just a few little quick exercises to get a sense of how massive you are and how much pushing it takes to move yourself. They said, okay, you've got your local tether on. Why don't you push away? I remember thinking, okay, look at the tether. It's really on. That's good. That's important. They don't want to float away.
You want to double check the tether.
Got to check the tether. Even though I have a safety tether on, I don't want to end up at the long end of my safety tether.
I'd have way more tethers.
My safety tether was on. I looked at it. I made sure that the little gate was closed so it couldn't come off. And I pushed away. And I went away a couple of feet, and the safety tether went tight. Sorry, the local tether went tight. I bounced back on it towards the space station, grabbed those handrails again, and I said, okay, I'm done. We're good to go. And we started the EVA, and I think the whole process took a few minutes. And the feedback I got after the flight was good, very quick, efficient start to the EVA. It was a good way to start my first EVA. And off we went, handrail over handrail, down the space station's pressurized module, train of pressurized modules, into the shuttle payload bay to begin our first EVA.
Yeah, wow. I cannot imagine. I imagine, like, just you talking about it kind of made my heart beat a little bit, because just there is a little bit of there's the stress of, like, okay, I'm in the vacuum of space. But I mean, the fact that you had the tethers on, you had a massive amount of training is really helpful to kind of get you in the right mindset and kind of prepare you for how you're supposed to move, appropriate ways to go forward.
Yeah. And NASA always has a lot of backups too, Karina. As you know, you need backups in spaceflight. So remember I said we had a safety, we were holding on to handrails doing EVAs always, but we had a safety tether that went back to the airlock, and we put down a local tether. So you think you've got at least 3 ways of staying attached to the space station: your hands, your local tether, and your safety tether. Maybe sometimes you only have 2 of those 3. But you also had a tiny rocket pack. Maybe rocket pack's too grand a word for it. But a
it's something
tiny
to propel you.
propellant pack attached to the back of your suit. It was called the SAFER, the Simplified Aid for EVA Rescue, SAFER. And if you somehow became genuinely unattached from the space station, like you let go, you didn't have a local tether down when you let go, and your safety tether back to the airlock broke, you would now be floating away. And in the days of the shuttle, in the days of spacewalks from a free-flying space shuttle, in other words, you're in the space shuttle, they open up the payload bay doors, you go out that airlock, and you go and do an EVA. If you became detached from the space shuttle there, heaven forbid, the space shuttle could be maneuvered to go and get you. But the space station didn't have that capability. So we carried this little jetpack called SAFER on the back of our suits. And the way it worked was had a battery power and a supply of cold gas, of nitrogen, pressurized nitrogen in bottles, and tiny little, really finger-sized jets, 16, I think, of them all over the side, back and sides and top and bottom of this thing. And if you became detached from the space station, you were supposed to pull out the hand controller from this and turn on the hand controller, and the system would stabilize you, and then fly. And then, those noises are probably exactly what it would have sounded like in the suit. You fire the thrusters to take you back to the space station. And there was training on this. We used virtual reality training where we would wear goggles that allowed us to see a simulated space station. We'd have a real hand controller, and the software mimicked the behavior of the hand controller, the system, the suit perfectly. I say perfectly. I never actually used the system in space. Sometimes I wish I had.
Yeah, just to have kind of just see how secure it was, and if you
how much fun
to use it. Yeah,
I wanted to see how much fun it would be to fly around like this. You've seen pictures of the manned maneuvering unit, that large self-flying spacesuit propellant system that was used in, I think, the early 1990s by shuttle astronauts to move around. This was a mini version of that. That looked like so much fun to fly.
Let's talk about maybe water accumulation in suits, because this has come up in conversation just before with us talking about some of the things that have happened in EVAs. And is there any kind of cutoff point where NASA eventually says, oh, you got too much water in your suit, you have to get back into the space station?
I'm sure if the astronaut doesn't say something first and just make a decision locally, which astronauts are empowered to do, then yes, mission control is going to weigh in and say it's time to terminate the EVA. We had two problems with my suit on my first EVA. One was fan speed wasn't staying constant; it was gradually declining, which could have been evidence of, say, worn out bearings in this fan. And this fan was a fan and pump, was pushing clean air around the suit for me to breathe, and also pumping water around to keep me cool. Two things that have to happen in the suit for the suit to be safe to wear.
Yeah. For
the EVA to continue. Mission Control never told me about the fan problem, but they were very aware of it, I learned later. And they were monitoring it to see how degraded the fan performance was. And obviously
you were like a guinea pig?
In a good way. Obviously, and I'm happy about this, they decided that it wasn't so degraded that the spacewalk couldn't continue. And that was good.
Fair enough.
The other problem we had towards the end of the EVA was that I got a little bit of water. The oxygen, by the way, is blown in over the top of your head and blows down the faceplate. And this does two things. It keeps the faceplate clear of condensation, this dry oxygen coming in, but it also puts the freshest oxygen right next to your face where you'll breathe it. There was water in that system, and it was being sent, little rivers of it, small rivers were being sent down the inside of the faceplate. I didn't use that EMU, that suit again, at least the upper torso part of it, after that EVA. I think my more experienced crewmate got it for the second EVA. Because if it had led to real trouble, he would have had more training and easier. He would have found it easier to deal with than I on my first or second EVA, I suspect. But that was the same hard upper torso, essentially the same spacesuit that the European Space Agency astronaut wore a couple of years later when they had that very significant water event in the helmet, where there was a large glob of water, and there was I think, real risk of the astronaut wearing that suit drowning before they could get back to the airlock, repressurize the airlock, and take off the helmet. They made it back. There are probably some strategies for dealing with that kind of problem. The side of the helmet had a vent right here, and that vent had a lock, and you could unlock it and then open the vent. And maybe you could have got the water to go out, some of the water to go out the side vent. Maybe you could try and drink the water. That's a relatively safe thing to do with water. But if you put your face towards it to drink it, and it gets into your nose as well as your mouth,
then you run the risk of drowning again.
You now may suffocate. And so I think that astronaut did really extraordinarily well to stay calm and get back into the airlock in time, because they had a lot of water in the helmet. But that could have been me a few years earlier. Something went wrong with that suit, and I've never heard the full story about what happened.
Yeah, that is kind of that's one of those things that it came up in conversation a few years ago with us, and I didn't even realize it was a thing. Then I read about that one story, and it's all these little things that are. Yeah. I mean, yeah, the suit has to be pressurized and has to have forced air, because there's the deep cold of space, and there's also like needing, and
you get hot too. I mean, space is a place where heat doesn't get conducted away. It only moves through radiation, and it's very well. Mostly, it's rejected through radiation. Now, the spacesuit is too small to have radiators. It couldn't have giant butterfly wings on the back attached as radiators, because, well, you wouldn't be able to do an EVA. So instead, it uses an ice pack, and the ice sublimates. It basically sort of boils off and takes the heat with it. So you're rejecting your heat by rejecting water molecules, essentially, that are warmer than when they started. But when you think of all the things that could go wrong with a spacesuit, you could become untethered and float away. The oxygen system could fail. The cooling system could fail. The suit could develop a leak. Any number of things go wrong. You generally don't think of the issue of drowning in the suit. And it just goes to show that, spaceflight, as much as we've practiced it carefully and learned many of the problems, there are new problems out there waiting for us, and we have to have conservative designs and conservative operating principles so that those things, when they happen, don't kill people.
Oh yeah, that's task one. Make it so you can actually get the job done and not die.
Imagine if that spacewalking European astronaut who'd had the water problem had been out on a solo spacewalk. Now, we don't do solo spacewalks, but this is exactly why. If something goes wrong, you need a buddy out there to talk to you, figure it out, see how you're doing, tell mission control, and potentially take you back quickly to the airlock. So when I say conservative operating principles, I mean things like conducting short EVAs, staying close to the airlock, having a buddy. Those are areas of conservatism in EVA planning that help keep people safe.
Reminds me of scuba diving, where it's just you're not even allowed to go into the water for more than a minute without your buddy. So
don't go without a buddy. That's right. And don't go without a reliable buddy, somebody you know and trust who's had the same level of training you have.
That's a fair point too. Yeah, for sure. So that one time that you actually had the water problem, would you say that was the most difficult EVA that you performed, or was there another one that was more difficult? Or
well, the water problem was a minor problem for me, more of an annoyance than at the time. It didn't seem like a safety threat. It just was an undesirable performance of the suit. And again, as I said, it was near the end of the first EVA, I think. The things that made EVA difficult were the tasks we had to do. And I think one of the hardest things Bob and I did was roll up the multi-layer insulation, we called it MLI, on top of the cupola, underneath the cupola, around the cupola. The cupola launched with this MLI, this sort of white spacesuit material wrapped around it, and held on with Velcro fasteners and so on. And we had to go and roll it up. Now, it's sort of like rolling up a sail or a tent on the ground, except you can't use gravity. So, for example, if you're rolling up a tent, what do? Well, the first thing you do is you lay it out very flat on a flat piece of ground, and then you fold it in half, and then you get the air out, and then you fold it in half again, and then maybe at the end, when it's roughly the right size, you roll it up. You put it in a bag. And gravity allows you, for example, to lean hard on that and keep the package small as you're rolling it or folding it. Well, in space, you don't get that assist from gravity. If you're rolling something up, you not only have to do the rolling motion, but you have to constantly compress it. You can't lean on it. You have to put hand underneath on top, perhaps, and compress it as you roll it. So that when you are done, you have a package that is small enough to put a tether around and attach to the back of your suit and head back to the airlock. And it's just really hard. And what are you holding on to while you're doing all this as well? If you're using, you could sort of roll a tent with one hand, right?
Yeah.
It takes two hands in space, but you need a third hand to hold on to something so you don't float away while you're doing all this. It's
and
holding
also,
things up.
The gloves are super clunky, like these fat fingers. Like I can hardly imagine the effort you'd actually have to expend trying to roll something tight with those big monkey hands.
And you're right. The gloves make it really challenging. In fact, one of the things you learn early as a spacewalker is don't ever hold on to anything like this. It's just too much effort to curl your fingers. You can do it, but you don't want to be doing this for hours. No. So when you hold on to something, you just hold on to it gently like this, and you use the friction between the rubber of your gloves and whatever it is, the handrail you're holding on to stop your hand sliding off. But you don't actually grab handrails, for example, as tightly as you possibly can. And there's no need. You're floating around. You're weightless. The tools are weightless. You don't need to exercise that much control.
Yeah. A lot of the hard parts are taken out of the equation, but I think we take gravity for granted. It's very, very nice to have, and just for little things like rolling up a piece of equipment. Well, could you talk about maybe the best part of being on a spacewalk? Is there a best
absolutely.
part, or because we've talked about difficult stuff?
The best part, again, like so many aspects of spaceflight, in a way, the best part for me was probably the camaraderie, the part of being a big team, doing something important, interesting, unusual, difficult, challenging, but really amazing, which is assembling the International Space Station. Occasionally you got to enjoy the other best part of the spacewalk, which was the view. And I remember a couple of instances. Once we were connecting wiring for heaters on the underside of the International Space Station. And before you made a connection in space, they wanted the folks on the inside of the space station to turn off power to the thing you were about to use, disconnect, connect. And they said, well, we're not quite ready for you. We need you to wait 5 minutes while we go send somebody to turn off the power for this thing. And they said, just enjoy the view. And hardly ever does Mission Control say, take a break for 5 minutes and enjoy the view. So that was a real gift. And I remember I was holding on to handrails. I remember pushing the handrail up so that my head went down. I looked down at the earth below me, and I was coming up over the UK. And it was, I think early-ish morning local time. So the sun was shining obliquely, and it was thin overcast. You could sort of see London through the overcast a bit. And I remember looking down thinking, wow, I used to live down there. How interesting to suddenly see it from up here. Another time I was installing handrails, and these times could have been separated by mere minutes, right? But I was installing handrails, and I noticed this bright light, but not from the sun, from below me. And I looked down, and as far as the eye could see below me, it was gold. I mean, bright gold, like illuminated gold, jewelry gold. And wow. I looked down, and I was over the Saudi Arabian peninsula, and it was gold as far as the eye could see. It was just beautiful. So there were many moments like that, but they were brief moments where you got to see some spectacular views. And it's different from seeing these views from inside a spacecraft. You feel closer to them because you only have a few inches of air and, I don't know, 1/4 of an inch of plastic face shield between you and hundreds of miles of vacuum and then the thing you're looking at.
Yeah, but it sounds like it was really special, and just, gosh,
It was special. It was a
You can't really
beautiful
capture
experience.
that in a photograph even. That's just kind of, that is amazing.
Yeah.
And I envy you. So
I'd like to go do it again. So
fair enough. I think a lot of folks would, who'd ever been on these missions. And you say you've actually kept in touch with your crewmates. Do you guys ever like kind of reminisce and talk?
we do. We reminisce about things. We also talk about the future of spaceflight a lot and other things like that. So, yep, we do reminisce. But mostly
Fair.
the reminiscing, I think I do on my own. By I see photographs of other people flying in space or views from space, or sometimes I see the photographs I took or were taken of me, and those bring back a lot of memories.
There's this one photo that you always had on the Blue Origin site, and I teased you about it for a while because it seemed like you were taking a selfie deliberately in space. But
That's me hanging from the bottom of the space station, I think. Yes.
which EVA was that?
I think
Do
that
you
was.
recall?
I'm trying to remember. I think that was EVA number 3.
Ah, okay. So you're already a learned scholar of spacewalking.
Somewhat slightly experienced. How about that? Slightly experienced.
Fair enough. Did you ever find yourselves in situations where you had to hack something together quickly, like sort of using gray tape or duct tape? This has come up in some folks talk about the necessity to do that on the space station before, and I was wondering if you'd run into it.
No, not as much as you would expect. We've all seen Apollo 13, which is really one of my favorite space movies of all time, where duct tape and ingenuity were really central to the plot. I would say the thing that I hacked, that most astronauts I knew hacked the most, were the procedures. We would launch with a set of procedures that we thought were going to cover not just the tasks we had to do, but all the contingencies we could reasonably foresee. And then something would change, and you'd need to do something else. And you'd have to take the bits of the task, the bits of the procedure that you developed, and rearrange them, or add things, or delete things. And so we were constantly hacking our procedures. But we tended not to hack with the hardware, because I think by the time I flew in space, people knew what tools they needed. They knew what spares they needed. We didn't do the kind of fun stuff you see in Apollo 13 with duct tape and cardboard and filters that weren't the right size, because people had learned that lesson. Now, you didn't fly a vehicle with one size filters and dock with a vehicle with a different kind of filter. If we were making that system today, both vehicles they'd use a common filter, so that in a crisis you could just go
you could swap it out
from the other vehicle.
Absolutely.
Just swap them out.
That's
Arguably, they should have done that in the Apollo program, right? That would have been the really. I mean, it was what they did was really clever, and they got everybody home safely, which is all that matters. But an even cleverer way to have solved that problem, with hindsight, it's easy to say this, would have been not to have that problem, to have common filters in the two vehicles.
Yeah, you designed the
And then
solution.
we'd never. But how boring would that be? We'd never have heard the wonderful story. People wouldn't have had to use their creativity.
And Tom Hanks wouldn't have gotten to make that movie.
Tom Hanks wouldn't have made a movie. And it's an inspirational story. I think a lot of people really have realized that kind of quick thinking and the ability to cobble things together on short notice from the available supplies is actually a real skill, and not just in spaceflight. In the whole of engineering, that's a real skill. The ability to take things that weren't meant to do a job and in a time of need, make them do that job for you.
So you have to be physically and mentally adept, brilliant, and also MacGyver.
You have to be able to be a MacGyver. But fortunately, we didn't do too much of that on my 2 space flights.
Well, that's lucky. Because I often wonder about that, and like how often does that really come up? And nowadays, it seems like there's always somebody living on the space station, but it's just like, oh gosh, imagine there's little things you hear about, like the leaking problems, especially towards the Russian part of the space station, where they had to kind of lock that down and fix some things, and it's been up there a little while, so there's little things going wrong with it. So I often wonder.
I have a great example of somebody being a good MacGyver. A colleague of mine flew on the space station early, and he was a scientist. He is a scientist and a great DIY person. And he wanted to drill holes in something metal, and I forget why. I think he was improving on the table that the first space station crew had assembled from spare parts, because the space station flew without a table. He was worried about those little bits of metal that fly off when you do drilling or machining on things. Those bits are called swarf, and he came up with an ingenious way of containing the swarf. He put a large bead of shaving foam on the metal before he cut it, before he drilled into it. And that both acted as a lubricant and coolant for the metal, but it also trapped all the little metal filings that were liberated by the drilling.
Shaving foam.
Isn't that clever? So,
yeah.
There are always ways to be clever and have a first in space by inventing a way to do something in zero G that people have done here on Earth all the time. We use gravity, right? All that swarf falls down into a bin under the lathe or the drill.
Oh, yeah.
And it's collected, and that's easy. You don't have to worry about it floating around and getting in your eye. But in space, you have to worry about that. And he came up with this really clever solution.
And I imagine probably 100 other solutions for other little things too.
Yeah. Necessity is the mother of invention, as they say.
Yeah, that is true for sure. I wanted to close today's interview with a question that kind of it came up last night, so I apologize for not kind of having it prepared. But I thought about this, and you were mentioned kind of like maybe wanting to go back to space in the future, but there's a lot of focus on the moon these days with the Chinese station and Artemis 1, which is delayed, but it's hopefully Tuesday, I hope. If you had a chance to work on the moon, would you go out there? I mean, with your kids?
It's not a hard question, Karina. Absolutely. Sign me up.
Yeah.
I've wanted to walk on the moon since I was a young boy, and I didn't obviously make it to the moon. I'm not sad about that, because I had a great time flying in space and in the career that prepared me for that, and ever since. But I would really, really, really love to walk on the moon. That would be another dream come true. So absolutely, in a heartbeat.
Wow. What is the ultimate extent of time that you'd be willing to share? Like, because, you have a little bit of gravity. It's more stable than just kind of floating in space to some degree. It's also kind of a meteor shooting gallery, but but at the same time, it's more stable. So how long would you be willing to actually live there?
It's a good question and a difficult one to answer. I think I got two answers for you. One is it depends on what kind of facilities they had. If I had to go live in the capsule I landed in, like say the lunar module for Apollo, if I had to live in that, then probably a reasonable limit's days or a week. If you could go out of that lander into a larger moon base, then potentially a very, very long time. And then I think something else sets the limit. It's not how long could you put up with it as a living condition. It's how much do you have to do there? Do you have enough to keep you busy and feeling useful? Because having a job to do is really a great thing. I mean, it gives you purpose. It keeps
your mind
busy,
occupied.
Keeps you occupied. If I didn't have a job, the answer would be not that long. And if I had something to do, whether it be science or engineering or maintenance or construction, then potentially a very long time. I'd love to spend 6 months or a year on the moon, I think, with the right facilities. And then the limit becomes maybe radiation or some other medical limit. How long can they leave you up there before they need to get you home and give you an ultrasound and x-rays and worry about the radiation exposure you've had on the moon, which could be significant.
That's the other thing. And I hadn't thought about it till you mentioned it, where it's just, we haven't really done a lot of studies on folks living on the moon where they need to actually have x-rays for the lack of, they don't have Earth's atmosphere to kind of protect them from the sun's radiation, and they would have also kind of maybe even bone density problems again. So there's all sorts of things that come up just for living in space. or off the
Yeah.
planet.
I think the bone density problem is largely solved through exercise. I think the medical community in spaceflight is, I think, essentially in agreement that we know how to control bone density loss and muscle mass loss.
What about vitamins? Or are there lots of
exercise? It's exercise. You
Fair
give
enough.
people plenty of exercise, and space station crews do 2 hours a day, an hour of weightlifting and an hour of aerobic exercise. And we've had astronauts come back from the space station with better bone density than they went up with because they're just exercising a lot, and that's good. But there are new problems. There's the spaceflight associated neuroocular disorder. There is the radiation problem.
Yeah.
It's not that new, but it's not a solved problem by any means. There are other things going on that we will need to get better at, to understand better and have countermeasures for if we're going to send people into space for a long period of time.
Space,
they're not all solved problems.
Yeah, with access to space getting less expensive, I'm sure that's the solutions for that are right around the corner to some degree.
The good news, I think, from this point of view about access to space getting cheaper is it means you don't have to send one person for a year. You could send 4 people for 3 months each. If the access is cheap, you don't have to do one long mission. And that means you don't have to subject people's bodies and minds to the rigors of a really long mission as much. Now, if you want to go to Mars, it is a long mission. There's no way around that. But inexpensive access to space will help with these medical problems.
Yeah, for sure. I still don't know why Elon is fixated on Mars, but it just doesn't seem...
It's a beautiful planet. I think it's been in people's minds for centuries, right? Everyone wants to know
with the storms,
what would it be like to live there?
The extreme cold. I'm just... I don't know. I would be hesitant, but that's me. I would actually almost prefer to aim for a kind of constructing one of those workable kind of cryo sleep systems, and then aiming for an exoplanet because there are super Earths out there.
There are.
What the heck?
Hopefully with manageable gravity and...
Yeah, that's the other thing.
Yeah, and fauna that are not dangerous. That's also important. No
well,
land
if
sharks.
it wasn't for certain events on this planet, the dinosaurs would still be here. So, yeah.
And trying to eat us.
The beasts would have to be somewhat friendly.
See the end of the movie Don't Look Up for a really good example of that.
Oh, yeah.
Have you seen Don't Look Up?
I have. It was pretty funny.
Yes. No spoilers here, but it's a good movie, and the ending is poetic.
Agreed. Okay, well, I have actually I think we've gone a half hour over what I thought to do today, but I really appreciate you making the time, and it's
been fun.
It's been so good to see your face again and just chat and actually talk about your
nice
missions.
Always fun to talk about space. So anytime, Karina.
Thank you very much for joining us on today's extra special interview. I really enjoyed having the chance to introduce you to one of my oldest friends, NASA astronaut Nicholas Patrick, and talk about his time at NASA. If you liked today's episode, please hit the like button and remember to subscribe. You can also keep up with this podcast at aerospacery.com. Take care and happy rocketing, everybody.